All right, so our Pythagorean theorem, a squared plus b squared equals c squared. Let me just write this off to the side here for you. It doesn't really matter where a and b go, but where does c have to be? Yeah, c has to be the hypotenuse, so a squared plus b squared equals c squared. Also, typically you'll see the angles will be labeled with the capital letters across from them. So like if this is side A, angle A would be across from it. This is how you'll see the triangles labeled. If this is B, angle B is across from it, and then C has to be your right angle. So Pythagorean theorem, a squared plus b squared equals c squared. And then the other thing we did was sine, cosine, tangent, all right? Sine equals what over what? Opposite over hypotenuse, good. Cosine is adjacent over hypotenuse. Tangent is the TOA, that would be opposite over adjacent. Okay, that's a big review of what we did last time. These first few, we're just going to review that. All right, so number one, Pythagorean theorem. I called what you're looking for X. You could call it whatever letter of the alphabet you want. If you want to change it to A or B, like be my guest, doesn't matter. This would be X squared plus 8 squared equals 12 squared. And so then we're going to square those. So, and remember, you get a calculator. So, you know, if you want to lean on that, you can. 8 squared would be 64, 12 squared, 144. Subtract over the 64. $80. And then square root. Honestly, dealing with the roots is probably the hardest part of these problems because you're going to have to split that. Now, 4 will go into 80, but you want the biggest perfect square. Try it. You get a calculator, so try a few things. Try 80 divided by 36, 80 divided by, well, 25 is not going to work, but 80 divided by, you know, a few of your perfect squares until you get one that works. You want to try the bigger ones before the smaller ones because you want the largest one that's going to work. So what did you find that's going to work? Good. 16 times 5 will give you 80. And then the whole point of that is your square root of 16 is 4. So 4 square root of 5 is your final answer there. I made this next one of those locker combination ones that if you memorize them, you can just state the answer. If not, you have to work out the Pythagorean theorem. 7, 24, 25. Now, if you work it out, will you get the same answer? Yes, it's just that's a whole lot less work. What was the smallest triple that I told you? If nothing else, please remember this one. 3, 4, 5. If you, I mean, like work with me, okay? Like 3, 4, 5. If you don't memorize the other ones, at least give me 3, 4, 5. All right, these are going to involve sine, cosine, and tangent. Anytime you bring an angle into the picture, that's where you need trig, okay? So this is our angle that's labeled. That means 9 is the what? Opposite, good. I'm writing this down. You don't have to label it if you don't want to, if you can hold that in your head. I'm just writing it down for you. X would be the adjacent. So do we want sine, cosine, or tangent? Good. Tangent of 53 degrees equals 9 over x. Now I worked you through all the algebra of how this happens last time. I want you to be able to just type it in the calculator. What would you type in your calculator to get this answer? Good, 9 over tangent 53. And again, you can refer back to the notes from last time. You'd multiply the x over and then divide the tangent over, but I don't want you to have to do that every time. Just get in the habit of when you see the variable in the denominator, here's how you're going to type it. How many decimal points? 3. It's the first 3 that you see. Anyone feeling brave? What did you get? Good. 6.781. Yes, so if you want to round, you could do 6.782. So I would take either answer. Here's my thing though. This is like, you don't have to think at all, which is like, I'm not telling you to not use your brain, but it's like, you know, why do more work than you have to? I would just take the first 3. All right, X is your point of view. We're looking for the angle this time. 10 would be the what? Good, that's adjacent. 14 is the hypotenuse. Good. So do you want sine, cosine, or tangent? That would be cosine. Now it's cosine of x. It's always sine, cosine, or tangent of the angle. So it's cosine of x equals 10 over 14. So to get x by itself, you have to anti-cosine. It's cosine inverse. How do we get that on the calculator? Good. Second cosine. It will put the cosine with a little -1. Put 10 over 14, close parentheses, and that will give you your answer. So you have to like uncosine. Anyone feeling brave? What did you end up with? Good, me too. Now, I won't take off points for this, but because that's an angle, what should you put with that? You should put degrees. And I do encourage you to get in the habit of putting the degree symbol when it's an angle, because you're going to have to keep the sides and the angles separated in your head to make sure that you like know one's an angle and one isn't. All right, so down here, this is your point of view, this angle theta that's labeled. That means 15 is the what? Good. Opposite. 8 would be the adjacent. 17 is the hypotenuse. All right, don't look at these for a second. I'm going to explain to you what those are. Sine would be what over what? Good, so that would be 15 over 17. Cosine would be what over what? Good, 8 over 17. And then tangent, opposite over adjacent, so that would be 15 over 8. I didn't harp on about this last time, but since this is the second class we're talking about these, I want you to pronounce them correctly. If you say it correctly, you will think it correctly, and then you will put the correct thing on your paper, okay? I know this is like me correcting your grammar, but one way is right and one way is wrong. This is not sin, it is sine. So I want you to write them out how they're spelled, at least this once, just humor me. That's sine. This is not cos, and I'm gonna correct you if you say that, all right? It is cosine. And this is not tan, we are not at the beach, unfortunately. It is tangent. Please say them correctly. Again, the reason I harp on about that is because if you say it correctly, you'll think it correctly, and then you'll get the correct answer. These are the other three trig functions. And I'm gonna complain for like 1 second if you let me. I wish that in geometry, just for like 1 second, somebody would go, hey, there are these other three trig functions, and all you do is reciprocate them. And then like when I go to show it to everybody, it wouldn't be such a big deal. People get like all emotional about these, like, oh my gosh, what on earth is that? There's just these other three trig functions, and they're just the reciprocal, all right? This one is CSC, that is cosecant. That's how you say it, cosecant, and it is the reciprocal of sine. There is no reason to get upset about this. If sine is 15/17, this would be 17/15. That is literally all it is. Nothing to get worked up over, okay? SEC is secant, and it's the reciprocal of cosine. Literally all you do is flip it over. So if cosine is 8 over 17, secant is 17 over 8. This would literally take 3 seconds for them to mention in geometry class. Do you know what I mean? Like, oh, by the way, there's these other three. There's only 6, by the way. It's not like I'm going to show you more later. Like, this is all that there is. I just wish they would mention it. Right? And this is not cot, it is cotangent. And it's the reciprocal of tangent. So that would be 8 over 15. That's all that they are, okay? It doesn't seem like anybody got worked up over that. I'm used to people going, oh my gosh, what on earth is this? And getting all upset, but you guys handled that, so nicely done. Let's try it one more time though, all right? In order to do this, we're gonna have to find the missing side using Pythagorean theorem. So this would be a squared plus 4 squared equals 14 squared. We're just gonna find that missing side first before we can do the rest of this. So that would be a squared plus 16 equals 196. Subtract over the 16, that's going to give you 180. And then square root. Go ahead and use your calculator. Try 180 divided by some stuff. Try the bigger numbers first, because I'm going to go ahead and tell you 4 will work, but there's one bigger than 4 that's going to work. So try 180 divided by some of the perfect squares until you get something that's going to divide out nicely. Anyone find it? 9, I think there's one that's bigger than 9. Yeah, bigger than 9, 36. See, because 9's not wrong and 4's not wrong. It's just you want the biggest one. So 36 times what? 5, good. And so that would be 6 square root of 5. So we're going to do the exact same thing we did in the previous question, just use these to answer the questions. All right, sine would be what over what? Good. So for this triangle, that would be 6 square root of 5, good, over 14. Now that will reduce, Ms. Cole, do we have to reduce them? Yeah, you need to be able to reduce a fraction. 6/14, they'll both divide by 2. So that'll be 3 square root of 5 over what? 7, good. All right, now let's do cosine. Cosine would be adjacent over hypotenuse. For this triangle, that would be what over what? Good, 4 over 14. And then you're just going to reduce that. What would that one reduce to? 2/7. And then tangent would be opposite over adjacent. That would be 6 square root of 5 over 4. And that's going to reduce 3 square root of 5 over 2. Everybody still with me? Okay, I know we're all tired. Thanks for hanging in there. All right. For these, all you're going to do is reciprocate them. So flip this over. It would be 7 over 3 square root of 5. Now you do have to rationalize that. So you would multiply by the square root of 5. It would give you 7 square root of 5. Now usually it's over 5, but you have to do 5 times 3. So 15. This one we catch a break on because you're not going to have to, there's not a root in it. You're not going to have to rationalize anything. This is 2/7. So if you reciprocate it, 7/2. And then this one, flip it over, 2 over 3 square root of 5. And then you have to rationalize that. It would be 2, and then what? Square root of 5 over, now you'd have to do 5 times 3, so 15. Is everybody okay? I know you're all like sleepy, but we're all right. Okay, I'm gonna keep going a little bit. I'll give you a break when we get like halfway through this, all right? So that was kind of a review of what we did last time, and then I introduced you to these other speech-big functions. All they are is the reciprocal of what you did before, okay? Now we're gonna do the word problems, pep talk. Every one of these is gonna be a right triangle. Again, a triangle has how many sides? And how many angles? 3. Okay, like your world is very small. If you get stuck, make something up. It's gonna be a right triangle, okay? But you do have to read and interpret what's going on. Also, because there's story problems, you're gonna have to put units. So make sure you put units in your answer. That's like the feet or the meters or the degrees or whatever, okay? A ship is offshore from a vertical cliff known to be 100 feet in height. All right, go ahead and draw yourself a right triangle. This is the ship out here in the water. This is like the water down here. And then this is the vertical cliff. Are you using your imagination? I'm not a great artist, so you're gonna have to use your imagination, okay? It says the cliff is 100 feet in height, so I can put the 100 right there. We take a sighting to the top of the cliff. Oh, angle of elevation. I need to mention that real quick. Let's put this in the space that we have here. Angle of elevation. That is the angle with the ground. Or in this problem, it's going to be the angle with the water. In other words, you're looking up. Elevation means looking up. So it's going to be the angle with the ground or the water or whatever's at the bottom of the problem. The other angle, like the opposite of that, is your angle of depression, which I don't really like the name for that because it sounds like it's a sad angle or something. All it means is that you're looking down. So it's going to be the angle with the sky or, like the vertical dimension of the problem. So like you're going to be up here, like looking down at something. Here's the thing. They're actually the same angle. So it frustrates me that we call them two different things. I realize the earth is round, but come with me on this. The sky and the ground would be parallel. Yes, like sky and ground, like I understand the earth is round, but like pretend you're a flat earther for a second, okay? Sky and ground, are parallel. You draw a line through that. Here would be your angle of elevation. Here's your angle of depression. They're congruent. Does anyone remember what those are called? I'll be super impressed, but I'm going to throw the question out there. Do you guys remember the unit where you had parallel lines and then you had corresponding angles? What are they? They are the same. They're congruent, but do you remember what they're called? All right. So yes, they are alternate interior. Ring any bells from 2 years ago? Sort of. Oh, okay. Well, they're the same. All right, anyway, so this problem here, angle of elevation is 25 degrees. So you're looking up at the top of the cliff, your 25 degrees goes there. How far offshore is the ship? So X is that part at the bottom, that's what you're looking for. I tend to call the missing part X. You can call it whatever letter of the alphabet you want. It does not matter, okay? So do we want sine, cosine, or tangent? This is your point of view. We have opposite and we have adjacent. Tangent, good. Tangent of 25 degrees equals 100 over X. And then you're going to type it in the calculator. It is no different than what we did last class, except you have to draw the triangle yourself. That's it. All right. How are we going to type that in? 100 divided by tangent of 25. 3 decimal points. 214.450. And then you have to put units. It's 214.450 what? Feet. So those are the only two differences. You have to draw the triangle yourself and you have to remember to put units at the end. Other than that, you're just picking sine, cosine, or tangent and typing it in the calculator. You have a 1 in 3 chance of guessing the correct trig function. All right, we'll try a couple more and then I'll give you a break, right? A 22-foot ladder is leaning against a building. It's gonna be a right triangle. Like they all are. Where can I put the 22? If that's the ladder, where does the 22 go? Yeah, good. This is the ladder, the hypotenuse right here. It's a 22-foot ladder leaning against the building. Makes a 70-degree angle with the ground. So 70 degrees goes right there. How far up the building does the ladder touch? Where does X go? Yeah, the opposite, right? So do we want sine, cosine, or tangent? Sine. The opposite in the hypotenuse. Sine of 70 degrees equals X over 22. And then you're going to put that in the calculator. How would we type that? Good. You're multiplying the 22 over. So 22 sine 70. A lot of people end up liking these word problems because they're really not that hard. You just draw a triangle, label it, and type it in the calculator. 20.673 what? Feet. But hold on to that because some of these you do end up finding the angle, and that in that case I do want the degree symbol on there because that's your units. Some people like to write it out in word like letters like D-E-G-R-E-E-S like degrees, but sometimes we are looking for the angle. All right, draw a right triangle. We know it's going to be a right triangle. A radio transmission tower is 200 feet tall. How long should a guy wire be? All right, a guy wire is like, you ever like see when people grow bean plants, you know how they take a wire and like attach it to the ground? It's like that. It's going to be the hypotenuse of the triangle, right? It's that wire that attaches to the ground. How long should the guy wire be? So this is X. Now this is a little tricky. It gets attached 10 feet from the top of the tower. So what is this vertical? Well, it's 200, but we're going to attach the guy wire 10 feet from the top. So 190. And we want it to make an angle of 21 degrees with the ground. So 21 degrees goes right there. All right, sine, cosine, or tangent. You got a 1 in 3 shot of guessing right. Sine. Sine of 21 degrees equals 190 over X. Slap it in the calculator. You'll have your answer. How do we type that one? Here's some of you typing it. What'd you put in? Good. 190 divided by sine of 21. 530.181 feet. That's a long wire. It was a tall tower though. All right, let's do a couple more and then I'll give you a break here. All right, number 10, you're standing on the top of a building looking down. All right, so you're up here looking down at your friend on the ground, an angle of depression of 56. All right, watch me do this. You can dot this in if you want to, but here's like the sky. The 56 degrees goes here. So it's also the angle of elevation. Again, they're alternate interior. The common mistake is people will put the 56 inside of the triangle, and that's not where it goes. I would just put it down at the ground and go, hey, they're going to be the same. All right, so that's our angle of depression. Your friend is standing 40 meters away from the building. So where can I put the 40? Does it go on the side or the bottom? On the bottom. All right, so 40 meters goes down here. How tall is the building? So that's X. Sine, cosine, or tangent? The tangent of what? 56, good, equals X over 40. You're going to multiply the 40 over and just put it in the calculator. So 40 times tangent of 56. These are like set it up, put it in the calculator. Set it up, put it in the calculator. So 59.302. I didn't make this one feet, it's different, just to basically make sure you're reading the problem. What is this one? Yep, meters. I do that every once in a while just to keep you on your toes, you know. Gotta make sure you're reading the problem. All right, we'll do one more and then I'll give you a break. Draw a right triangle. A 25-foot tall tree. So where can I put 25? If that's the tree, where does the 25 go? Like trees grow upwards, so that's the vertical, right? Cast a shadow 38 feet in length. So the 38 goes along the ground. Shadows go along the ground. What is the angle of elevation? All right, this time we are looking for the angle. So you do have to put the degrees because that's your units. Sine, cosine, or tangent? Tangent of X, good, we're looking for the angle, equals 25 over 38. And how do you type that one? Good, tangent inverse. And so you type that as, like, how do I get tangent inverse on here? Good, second tangent, 25 over 38. And so this is the angle, 33.340 degrees. So you do have to put that degree symbol for this problem because that's the units for your answer. And again, a lot of people will do this so that they don't forget. Either way, it doesn't matter. All right, so for the next one, we have an airplane flying 10,500 feet above the ground. So that's going to be the vertical distance. Has a horizontal distance, so it's going to be left to right, of 45,000 blah, blah, blah feet to a tree that's on the ground. All right, so go ahead and draw yourself the right triangle. The plane is 10,500 feet in the air. So again, that's the vertical distance. And then this number, the 45,000 and some, is the horizontal distance. So what is the angle of depression from the plane to the tree? You can dot in the sky if you want to, but the angle of depression is going to be the same as the angle of elevation. So I would suggest just go ahead and put your variable X right there. If you want to, it would look like this and they're alternate interior, but they're going to be the same. So I would just put it in there at the bottom. Because again, the common mistake is people will put it inside the triangle up here. Just it goes down here. All right, sine, cosine, or tangent? Good. Tangent of X equals 10,500 over that 45,000 and whatever other number. And then again, how would we type that since we're looking for the angle? Good, and good vocabulary, inverse tangent. So second tangent of all that mess. All right, I got 12.999999999. If you're at 12.999, that's totally fine. I know I've been harping on about 3 decimal points, but honestly, if you wanted to put 13 degrees for this one, I'm totally cool with that as well. All right, so 13 degrees. I'm sorry that says form. It should say from. I apologize. Right. Spell check doesn't catch it because form actually is a word, right? From a window 30 feet above the street, the angle of elevation to the top of a nearby building is 50 degrees. The angle of depression to the bottom of the building is 20 degrees. How tall is the building? This is a more complicated problem, all right? So we've got one building, we're 30 feet above the street. So here's our first building is 30. There's a taller building over here. So it said the angle of elevation to the top. So if we connect to the top of the other building and create this right triangle, that elevation to the top is 50 degrees. That's going to go right there. And then the angle of depression to the bottom is 20 degrees. So 20 degrees is going to go right there. So here we actually have 2 right triangles. How tall is the building? So here's your final answer. You want this distance, like this entire thing, but it's going to be a 2-part problem because you don't have all the information you need. Now look, if this distance is 30, that's this part of this triangle. Are you coming with me on that? Like if this is 30, this is going to be 30. The first thing we're going to have to find is the distance between the 2 buildings. We're going to have to find this horizontal distance because you're missing too much information. You can call it whatever you want. If I'm missing something, I tend to call it A or B. And you'll see why in a second, because I'm going to teach you how to store them on the calculator. I know you're all glazed over because you're tired. I totally get it. You're going to have to listen to me when I tell you how to do this because it's a necessary skill for the calculator. Okay, you're going to have to know how to do the button pushing. So I'm going to call that A. Everybody look just at the triangle on the bottom. 20 degrees is your point of view. Do we want sine, cosine, or tangent to find A? Do you see how we're using tangent a lot for these? Because you oftentimes don't have the hypotenuse. So tangent, remember how I said you have a 1 in 3 chance of guessing? If you're totally stuck, probably pick tangent because most likely what it is, right? Tangent of 20 degrees equals 30 over A. So how would you type that in the calculator? Good. 30 divided by tangent of 20. And so that's what we have for this distance between the 2 buildings, 82.424. Don't get rid of that. I'm going to show you what to do with that. But A is 82.424. Everybody watch. I want you to watch me do this, and then I'll give you a chance to do it. We want to be able to copy and paste that number. So what we're going to do is store it. While I have that sitting right there, do you see this button at the bottom right above on that says STO, S-T-O? Just watch me do this. I'm going to hit that button. It's going to put a little arrow, and then you can store it as whatever letter of the alphabet you want. Do you see all these green letters? A, B, C. Do you ever use the calculator to type a message to somebody else? You know how you do alpha, whatever. Okay. I always store as A, B, or C. They're the first letters of the alphabet, and they're also really close to the alpha button, so it just makes it easy. But you hit store and then do alpha A, enter. Store alpha A, enter. Store alpha A. I'm just going to say it a zillion times. Store alpha A, enter. Store alpha A, enter. Now, every time you do alpha A, it will copy and paste that number for you, so you don't have to type it again. Does this make sense for everybody? It's a copy paste. So now we're looking at the triangle on the top. We need to get this distance. I'm going to call it B. Again, I go with A, B, and C because if you have to store things, they're the easiest letters to store as. All right, so looking at the top triangle, we're going to have tangent of 50 equals B over A. And so what you would want to do is multiply that A over. So you're going to type in your calculator this 82.424 times tangent of 50. But watch how I'm going to do this. I'm going to hit alpha A. Let me make sure it's on the screen there. Alpha A, and then times tangent of 50. what it will do is it will copy and paste that value in for me and multiply it by tangent of 50. Isn't that cool? That's cool. It'll copy and paste for you. Okay, that's cool. What if I don't want to do that? What if I just want to type 82.424? You know how the telephone game works? How like if you tell someone something and they tell someone something and then like by the end it gets really messed up? If you use a truncated answer over again, your final answer is not going to be accurate enough. Your final answer won't be right. Like it won't be accurate to 3 decimal places, which it has to be. So you have to do it. All right. Did you get 98.229? Let's store that as B. So I have that sitting right here in my calculator. I'm going to hit store alpha B, enter. Store alpha B, enter. Store alpha B, enter. Now, how do I get the final answer to the entire problem? Because remember, we want this entire distance, the whole height of the whole building. Good, B plus 30. So what you're going to type in your calculator is alpha B plus 30. It'll copy and paste it in there for you, and that'll give you your final answer. So that is it, 128.229. Feet. Or wait, was it feet? Did you check? Feet, yes, okay. Most often it's feet, but it's a good thing to check because every once in a while when it's meters, then you don't want to write the wrong thing. So you can store and then copy paste those values, which is nice. All right. Next one. The eyes of a basketball player are 6 feet above the floor. He's 6 feet tall. All right. He's at the free throw line, which is 15 away from the center of the basket rim, which is 10 feet above the floor. Okay, here's what's going on. We've got this guy, he's 6 feet tall. We've got the basketball hoop, which is 15 feet tall. Oh, no, wait, no, it's not either. Sorry, too many numbers. How tall was that? 10. Sorry, he's 15 feet away. So this distance is 15. So he's 6 feet tall. The basket is 10 feet tall. He's standing 15 feet away. There we go. What is the angle of elevation from his eyes to the center of the rim? So what we're looking for is this angle right here. You have to create a right triangle somehow. You can't use sine, cosine, tangent unless you have a right triangle. So this is the angle that we're looking for. Now, if this entire distance is 10, what is just this amount right here? Good, 4. Why is it 4? How did you get 4? That's correct. Yeah, 10 minus 6 is 4. All right, tangent of x equals opposite over adjacent. So that would be 4 over, what is this distance? 15, good. And then how would we type that? We want the angle, so how are we going to type it? Inverse, good. I love that you guys are using good vocabulary. All right, tangent inverse, second tangent, 4 over 15. I will give you 14.931 degrees. All right, next one. A person is standing 150 centimeters from a mirror. They have an angle of elevation looking down to the bottom of the mirror. That's 12 degrees. Angle of elevation to the top of the mirror is 11 degrees. All right, so here's the person. Here's the mirror that they're looking into. And they're looking up to the top and down to the bottom. But you have to create this right angle in order to put your angle of elevation and depression in. All right, so the angle to the bottom was 12 degrees. And to the top is 11 degrees. So practically the same, but not quite. All right, what else can I fill in? Because we were given one other piece of information there. What else were we told? Yeah, they're 150 centimeters away. So this horizontal distance is 150 centimeters. All right, determine the vertical measurement of the mirror. It's really similar to number 13. What we're being asked for is this amount, but it's a two-part problem. you have to do the bottom amount and then the top amount, and then we're going to have to add them together, right? Let's just look at the bottom triangle. I'm going to call this distance A. Again, I go with A, B, and C if I have to store something. This is going to be a two-part problem. You would have tangent of 12 equals what? What over what? Good, A over 150. So multiply the 150 over what you're going to type. Please type along with me. 150 tangent of 12. I got 31.883. How do I store that? What buttons am I going to hit? Because we have to copy paste. What am I going to hit to store it? Good. Store alpha A. Enter. If you don't hit enter, it won't actually do it. So store alpha A, enter. All right, that gives us that part. Now let's do the triangle on the top. Let's call this B. You would have tangent of 11 degrees equals B over 150. So multiply the 150 over, you're going to type in 150 tangent of 11, slightly smaller, so 29.157, and then store that as B. Store alpha B, enter. Store alpha B, enter. So we got A and we got B. What are we going to do with them to get our total answer to like the whole question? Yeah, add them together, A plus B. So you're going to do alpha A plus alpha B. It will copy and paste those numbers in for you, which is super cool. And then hit enter. So the mirror is 61.040. Ooh, what were the units for this one? It was not feet. That is not a 61-foot mirror. Yeah, centimeters for that one. I'm going metric. Do you guys think we should go metric? No, stick with our feet and our inches. We're too ingrained in our ways. All right, one more. Adorning the top of the Board of Trade building in Chicago is a statue of Ceres, the Roman goddess of wheat. That's actually true, and you can Google that, right? So there's the building, and then the statue is on top of the building, right? From street level, 2 observations are taken 400 feet from the building. We have an angle of elevation to the bottom of the statue and an angle of elevation to the top of the statue. I can't talk, right? Here's what this would look like. You have this right triangle. We're 400 feet away from the building. Here's the building, and then here's the statue on top of it. It's a really tall statue of this goddess, all right? So we've got the building and we've got her standing on top of it. We have one sighting that's to her feet. So to the base of the statue right here. That one is this 55.1 degrees. And then the sighting that's to the top of the statue, that's this entire angle. It was slightly more, what was that, 56.5 degrees. This is going to be another 2-part problem because you have 2 triangles there. You have one inside of the other. So we're going to do 2 problems and then add or subtract our answers together, whatever we need to do. The goal is to figure out how tall is the statue. Okay, so let's look just at this triangle. We're going to find this distance right here. I'm going to call it A. Again, I go with A, B, and C. You can call it whatever you want. I go with A, B, and C because that's what you store them at. So it just makes sense, right? Why would you call it Q and then store it as A? You know, like call it what it is. So you'd have tangent of 55.1 degrees equals A over 400. Everybody go ahead and type that in. And please type with me. I always get somebody that's like, nah, I'll just watch. That's not going to work on the test. And doing the typing is a skill that you need. So please practice with me. Anyone feeling brave? How tall is the building? This is going to give us the height of the building. Good, perfect. 573.386. Store it. Store alpha A, enter. Store alpha A, enter. Do that before you even write it down so that you don't forget. Store alpha A, enter. Oh, And so I don't forget to say this. Somebody always asks me, actually multiple people always ask me this, how do I like unstore it? Like, how do I clear it? You can't. And I know that that really bothers some people. Like, you know how you want it to be like clear, like you want it to be empty? You can't do that. When you store the next A, you just cover it up. And then when you store the next thing, you keep covering it up. Do you understand what I'm saying? You can't clear it out. I know half of you are like, that really bothers me. You have to just get over it. You can't, I guess you could clear the memory, but I wouldn't. Now, if you clear the memory, you are now in radian mode. You have to remember to put yourself back in degree mode. So I suggest just get over it. Take a deep breath. Remember that you can't clear it out. You'll just keep covering it up with a new, if it'll make you feel better, do this. Well, don't do it right now because we're in the middle of a problem, but you can do 0, store alpha A, enter, and it'll store A as 0 if that makes you feel like it's cleared. But why? You know what I mean? Like just leave it alone. All right, now we're gonna look at the whole big triangle. We'll have tangents of, what was the other one? 56.5 degrees equals. Now, because that is this entire angle, your opposite side is this entire thing. It's the building plus the statue. I'm gonna call that B. Again, the reason why is it's the whole angle. So it's this entire side. All right, equals B over 400. Go ahead and type that one in. It'll be 400 tangent of 56.5. Store it as B. Store alpha B, enter. And I got 604.334. So B is this entire distance. A is just the building. What am I going to do with those to get this distance of just the statue? Subtract them. You're going to do B minus A. So in your calculator, alpha B minus alpha A, we'll copy and paste this in there. You'll get 30.947. And I believe it was feet, right?